Back on part 2 here, we're going to look at some special triangles and some trig functions that relate to them. So that will end our discussion this evening. The special triangles, well, the first one, the special triangle that we're going to start with, is going to be a right triangle, of course, and this right triangle has the same size legs here and here. So this leg is equal to this leg, and in that case, in this special case, it's called an isosceles triangle. And let's make we'll say this side, we'll take the simplest case. We'll say this side is 1. If that side is 1, so is this one, according to what I've stated, that the sides are equal, the legs are equal. We can use Pythagorean to come up with the third side, so see if you can do that while I do it. So I said 1 squared plus 1 squared equals the hypotenuse squared. Square rooting both sides, I get the hypotenuse equals the square root of 2. So I'm going to put that on the hypotenuse and ready to go with my trig functions. So if I take this angle as my angle of reference, we need to actually know what that value is, and we can find it out because we know the angles in any triangle add up to 180, and this is 90, and because these sides are equal, you'll recall from geometry that angles opposite equal sides are also equal. So what number must this be if it's the same angle here, and these two identical numbers add up with 90 to give you 180? They must be 45. So this is a 45, 45, 90 triangle, special triangle, and that's how we refer to it. Let me clean up this drawing a little bit. Alright, 45, 45. Now that I have the angle, I can actually find the trig functions of it, and I'll start that now. The sine of 45, so I'm using either one of these angles, I'll use that one, is going to be opposite over hypotenuse always for sine, and I'm going to get side opposite 1 over hypotenuse 1 over the square root of 2. That's the sine of 45 degrees. And it's interesting to note that triangles can be quite large and still have an angle that's 45 degrees. So this triangle, as long as this side equals this side, the angle will always be 45 degrees. Even if I go out to the moon and back, if I have equal sides, equal legs on a right triangle, this will be 45 degrees. And its side opposite divided by its side hypotenuse, no matter how large these sides are, the relationship will hold. Opposite over hypotenuse is going to be 1 divided by the square root of 2. Now we like to get the square root out of the bottom, and you recall how to rationalize. We multiply by square root of 2 over square root of 2, and then we get square root of 2 over square root of 4, which is 2. So this is the best form of the answer to sine of 45. Cosine of 45. See if you can calculate that for me. It's adjacent over hypotenuse. So looking in at that triangle up there, this triangle, what is adjacent over hypotenuse? You'll see this is side adjacent and that's hypotenuse, so it's kind of funny that we get the same thing. That will always happen on a 45, 45, 90 triangle. The cosine, the sine and cosine of 45 are always the same. So we're going to get 1 over the square root of 2 again, which rationalizes to square root of 2 over 2. Tangent of 45. That's a really funny one. So we're going to have opposite over adjacent. So let's look up here at the triangle. Sorry, making you dizzy. You'll be seasick by the time I finish this video. From this angle, what is side opposite divided by side adjacent? Opposite divided by side adjacent, 1 divided by 1. So I told you it was a funny one. So tangent of 45 is 1. So these are some actual angles that we know sine, cosine, and tangent for. Alright, there's another special triangle that can get us a couple more. So far we've got sine of 45 is square root of 2 over 2. Cosine of 45 is square root of 2 over 2. And tangent of 45 is 1. So we kind of group our answers all together there. And we can add to that list, so we can do 45s by looking at another special triangle, and that's an equilateral triangle. All 3 sides are equal. So when we have an equilateral triangle, all 3 sides are equal, the 3 angles are all equal and they add to 180. So what must they be? The only answer would be 60, 60, and 60. So I'm going to take this triangle. It needs to be a right triangle to deal with trig. This is not a right triangle. So I'm just going to drop a perpendicular here and just take this piece. And I'll actually move that over here. So I've got 60 degrees here. Now I do have a right angle here. But what would this angle be up here? Well, you can calculate it. 90 and 60 are 150, so this must be 30 for all to add to 180. Alright, so now there is a relationship also. So let's say, because we're going to cut this in half, let's say that our equilateral triangle had all equal sides and they are all 2. So when I cut this one in half, this became a 1 and this became a 1. So when I move this over here, I know this is still 2, this is 1, and Pythagorean can come alongside and help us find this. This is not the hypotenuse, this is a leg, so it's going to be 1 squared plus unknown side squared equals the hypotenuse squared. So in Pythagorean, the theorem, the hypotenuse is always by itself. So we have 1 plus side squared equals 4. Subtract 1 from both sides. Side squared equals 3. Take the square root, and we get s equals the square root of 3. So this unknown side is now known to be the square root of 3 from the Pythagorean theorem. So now it's all set to do sine, cosine, and tangent. Sine, we'll start with 60. Sine of 60 is opposite over hypotenuse, square root of 3 over 2. Cosine is adjacent over hypotenuse, 1 over 2. And tangent is opposite over adjacent, square root of 3 over 1, or just square root of 3. And we can do the same thing for the other angle, 30. So we'll go and look at this one instead of this one. So see, I don't think I can keep it in view. Maybe I can, a little bit. Alright, say I do sine of 30. So from the position of 30 here, what is side opposite over a hypotenuse? Side opposite is 1, hypotenuse is 2. 1/2. Cosine of 30 is going to be adjacent over hypotenuse. And tangent of 30 is going to be opposite over adjacent. 1 opposite is 1 over the square root of 3 is adjacent. 1 over the square root of 3. That needs to be rationalized. To get the radical out of the bottom, we multiply like this. Square root of 3 over square root of 3. And that will give us square root of 3 on the top and square root of 3 times square root of 3, which is square root of 9, or just plain 3 on the bottom. Alright, so that's it for tonight. We introduced the 6 trig functions and found some of the trig functions for 45, 30, and 60 degrees. Alright, keep that under your hat. Bring it, tuck it up under your sleeve. Bring it to class tomorrow in your mind so that you'll be able to work well on your problem set. So see you then. Have a good evening. Bye.